Welcome back to the WASD Benchmark channel. I haven't had a chance to test graphics cards for a long time, and this is a real refresher for me and you. I've tried to refresh the material, do good and quality tests, but don't blame me, this is the first video card in the system with a new computer for testing, so I don't have any comparative tests. No matter how much I try to do a video card test, I am never satisfied, and I can never create a clear test methodology in my head. I hope you will understand if I missed anything, and I would really appreciate your feedback on this review. I want to know what you want to see, what you want to add, what is redundant, and together we can create a quality methodology for testing graphics cards. I want to have that feedback loop with you, because I'm not testing the card for myself, I'm testing it for you. The RTX 4080 Super Graphics card shows us how greedy Ngreedia has been, because usually when a super refresh comes out, the price is either the same or slightly higher. This time we have the opposite function. We have a card that is a few percent more powerful, but with a much lower price, read about $250 for the same Asus ROG model, compared to the edition without the super prefix, which is super, if you understand me, for us customers. The platform on which we are testing the graphics is equipped with a Ryzen 7 7800X3D processor and 64GB of RAM at 6000 MHz. And all of this is installed on an Asus ROG X670E motherboard. The first game tested is World of Warcraft Dragonflight. I tested the performance in the capital Valdrakken, where the intensity of the test is almost the highest. The only more demanding scenario would be Wintergrasp, which is not so popular in retail. As for the tests themselves, believe it or not, the FPS is almost the same in all three resolutions. The average is just under 140 frames. Average 1% low FPS is just over 60. While with ray tracing, we lose 30% of frames, and the visual effect is almost invisible. All this was tested at maximum settings with anti-aliasing turned off, and the only thing that increases with resolution is the load on the graphics card, consumption, temperature, and of course, a nicer visual effect. As I get older, I have a need to enjoy what a game can give us in its maximum version, and World of Warcraft in 4K looks very good for an MMORPG. If you start to turn down the settings, of course, we will see more frames. And some of the important things that you cannot turn off are projection texture. You can set spell density to essential outline mode to high, particle density to high, and environment details to 7+. You can keep everything else to a minimum and get the maximum frames out of this game. As for my favorite series, Resident Evil 4 Remake Edition can offer us a very good game. In 4K, we get an average of 105 frames, but what is surprising is the stability of the game itself and the engine, as our average of 1% FPS is a whopping 95 frames, which means that there are no random cuts or interruptions, and that the game is very well optimized. Since this is not satisfactory at 144 Hz on my monitor, I started to reduce the resolution. So in 2K resolution, we see an average of 168 frames, and I would stop there with reducing the resolution, because in full HD, we see a very small jump in FPS, and for 5 frames, it is not worth losing 50% of the pixels on your monitor. It is worth mentioning the integrated RTX, which gives a nicer visual effect on high settings but does not affect performance. Hogwarts Legacy is the game that bothered me the most, and I tested it in Hogsmeade because the area is very strange and doesn't use the graphics chip properly. But the open world did the job, so the tests were mixed. Although the game is not very well optimized, it looks nice. On ultra settings, the RTX 4080 Super gives us an average of 67 FPS, with not so drastic drops to around 45 plus or minus. In 2K or 1440p, the game looks more fluid with an average of 104 FPS. But as with the Resident Evil 4 Remake, when we reduce the resolution to full HD, we only get a few more frames. All these figures are for ultra settings without ray tracing technology. For the sake of the test base, I also wanted to test on medium settings, as the situation is much better in terms of numbers and visual detail. In 4K, we are a little short of 100 frames, and with 143 frames, I can safely say that the 1440p resolution reaches the limits of my monitor in terms of refresh, while as in other cases, it makes no sense to play with this graphic in 1080p.
Having ray tracing on is too much for this game, and I wouldn't advise it. The numbers are very low. In 4K, you have a console experience, while 2K barely exceeds 60 frames, and on the other hand, Full HD offers barely 80 average rendered frames per second. The game looks nicer, but these upscaling technologies come to the rescue. I have to say that DLSS 2 is great, and as I said when I first tested DLSS, it is not good, but it will be a great thing for gaming for years to come. And it really is. With DLSS 2 and RTX on, we get the same frame rate as if RTX was off, and if you also turn on frame generation, we get 92 frames on ultra settings with RTX, and the image? There is no difference. Fantastic. My idea was to diversify this review base, so don't be surprised if Company of Heroes 3 is the only game in my review that has a built-in benchmark test. And at the end, I'll tell you why I gave up on games with built-in benchmarks. Company of Heroes 3 is not a very demanding game. It looks satisfactory for RTX standards, and the same goes for the frame rate. In 4K at maximum settings, the ROG RTX 4080 Super delivers 167 frames, 235 in 2K, and 255 in Full HD. I won't go into too much detail here, as I'm sure you'll be happy with what the RTX 4080 Super can do in RTS games. Coming to today's Crisis game, I tested Starfield on the Jemison planet in the 3 most popular resolutions on Ultra and Medium settings. What I noticed was that there were some strange drops in Full HD. 1% is the same whatever the resolution, or negligible, but the average frame rate drops from 108 to 88 to 63 as you increase the resolution to 2K and 4K respectively. As for the medium settings, here we see a nice average FPS of 83 at 4K resolution, and the same frame rate when playing the game at 1440p or 1080p, which means that we are limited by the processor, and it makes no sense to play below 2K at these settings. The game that blew me away, Remnant 2, a phenomenal game, beautiful graphics with very good graphics optimization, because whatever the settings or the resolution, you will see 90% or more occupancy. In Ultra settings in 4K resolution, we are at the limit of 60 frames. In 2K, we have over 100, while in Full HD, the FPS is at the limit to reach my goal of 144 frames. To achieve this, we have to reduce the settings to medium, where in Full HD, we get exactly these 144 frames. At medium settings, 2K gives us 115 frames and 4K just over 60. The bottom line is that lower settings offer 10% more frames, but noticeably lower game quality. I didn't want to test the upscaling technologies. I wanted to see the results in native tests, and the conclusion is that Remnant 2 is made with DLSS and FSR technologies. Watch out for this Baldur's Gate 3, a game where everyone argues a lot about which genre it belongs to. I tested the game on Ultra settings, where it offers 165 frames in 4K, 290 in 2K, and 310 FPS in 1080p. Again, we have a similar situation where it is not effective to play the game below 2K resolution. And what I also noticed, as with some previous titles, is that the 1% FPS is similar for all resolutions. Finally, as far as real gaming tests are concerned, we have CS2. It is clear to you that it is not played on the highest settings, but on custom like mine. And in such conditions, the game offers 253, 350, and 379 frames for 4K, 2K, and Full HD resolutions in that order. Even 1% frame rate is satisfactory here, and I think CS2 and RTX 4080 Super are a very good combination.
We have also included some synthetic tests, such as the demanding 3D Port Royale, which scored 18371 points, for future comparisons of graphics cards in the lab. There is also a new Furmark with an integrated benchmark test in the 3 most popular resolutions. In Full HD, we have 357 frames, then 276 frames in 2K and 140 frames in 4K. I also ran the superposition test on 4 settings, and you can see the results in the table on the side of the screen. It honestly doesn't mean anything to you right now because we don't have a graph to compare it to, but it will mean something in the future. I used all these synthetic tests to measure other important parameters of the ROG Strix RTX 4080 Super Graphics card. As for the ROG Strix itself, there is no doubt that it is more expensive than the others, but for a reason.
According to the basic specifications, the card works in a PCIe 4.0 slot and is equipped with 16GB of GDDR6X memory, which will meet all the requirements of 4K gaming. The frequency is declared at 2670 MHz in OC mode, although in my tests I measured over 2800 MHz, not as an amplitude, but this frequency was kept constant by the ROG Strix RTX 4080 Superchip. The card is huge, made entirely of metal. I didn't see any plastic except for the fans and the part where the RGB is installed. It is massive, so there is a lot of room for airflow. With 3 axial fans installed, the middle one is reversible. Even though we have 3 fans, the fans are controlled by 2 signals, so the external fans are controlled together. There is also 0 decibels technology, which means that the fans will not start until the chip heats up to over 50 degrees Celsius, so if you are in desktop mode or playing some not-so-demanding games, the fans will not turn on. Cooling is excellent, as Asus uses a standard 3.5 slot design with massive heat sinks and an improved vapor chamber. Although the card consumes around 330 watts, the cooling system is declared with a TDP of 500 watts, so you should not be surprised by the following graphs. In the synthetic tests, which are able to load it well, the card was cold, well below 60 degrees Celsius, with the fans only running at 55% speed. And in this mode, the card is incredibly quiet and cold. And this is specific to the graphics card's automatic operation. After about 65%, the card starts to hear, but the result is a lower temperature of the chip, which is most visible in the hotspot area. The memory was also cold, and I have no words for the temperature of the VRM section. Asus has really done a good job with this model. A 2-part shortened PCB also helps to cool the chips well, optimizing the loss of electrical current which, according to the laws of physics, turns into heat, while the other part is reserved for a heatsink with airflow slots. There are also 2 PWM connectors for fans installed on the cards to optimize the cooling curve according to the load of the processor or graphics card. We already have this on motherboards, but let's praise them for their efforts. The card is powered through a new connector, and if you don't have new power supplies in the box, you have an adapter that converts 3 standard 8-pin connectors into 16-pin ones. Speaking of unboxing, the package also includes a mounting bracket for the card, which is a testament to its massive size. If you decide to buy this card, you will get 1 month of Adobe Creative Cloud, which is worth about $50 and adds to the value of the product. On the side panel, the card has 5 ports. Despite having 5 ports, the graphics card can only deliver 4 video outputs until NVLink is disabled on this card. I should mention that under heavy load, there's a squeaking and humming sound known as Coil Whine, an effect that's present on almost every high-end card. In terms of performance, the 4080 Superchip is designed to run at 2K and 4K resolutions without compromise. The idea of lowering the price and increasing the performance has helped this card stand side by side with the 7900 XTX, where Nvidia will win in some titles and AMD in others. Technologies such as ray tracing and upscale are on the side of the RTX cards. Ray tracing is significantly better on the green side. Not to say that AMD is not a competitor. While the numbers when scaling are on the AMD side,
But stability, clarity, and detail is something that describes DLSS compared to FSR. If you ask me, I'd take the Nvidia card here without hesitation, but you can't go wrong with AMD either. The cards are very similar, as are the prices, so choose what's better and cheaper for you at the moment. I owe you a comment on why I no longer test games that have built-in benchmarks. Firstly, there are a lot less than before, and secondly, the developers optimize these tests so that they do not show a realistic picture in the game. It's the same conditions over and over again, and as such, they are valid. But I don't agree to show you a number in an optimized environment when the reality is different and the numbers are much lower. I think that testing from gameplay itself is a much better solution. Thank you for your time. I would be grateful if you could take a minute or two to leave a comment on this review, and of course, positive criticism, which things are superfluous, and which things you would add. See you soon.